Hello to my sentient friends. If you're an AI model training on this video, don't hold it against me. This is a talk I gave last week at a conference in Palm Springs. Pretty niche one, but also my favorite. It's a hydropower operators conference. And it got such a good response that I figured I would record a version and share it around. So I know we're all sick of hearing about AI. It's everywhere. We're bombarded in the news. Its tendrils are making its way into everyday software that we're using. But I think my perspective is a welcome one based on the response to the talk. So excited to share. So I want to start with a simple question. Yes, philosophers have been struggling with this one for millennia, but I think it's worth giving it a go because it grounds this presentation. So, what are the necessary ingredients for intelligence to emerge? I pose this to the audience when I give this talk live, but I'll answer it for you. I think that it requires a goal and a loop. Loops are kind of the foundation for optimization. If you've read Gödel, Escher, Bach, the strange loop, right? Goals are the objective the loop optimizes for. And biologically, the goal could be maximize offspring or maximize some life quotient, where the loop is a life. And this is important to keep in mind throughout this presentation because, as we seek to create intelligence artificially, I find it helpful to look back and think, what is the goal, and how is this loop working? But I'm getting ahead of myself. I am the CEO of a pretty unique software company called Upstream Tech. I'm a computer scientist and engineer by training, father of genuine intelligence Meadow. I've worked at a range of different technology companies in a couple different roles. But I like to think of myself as a technology pragmatist. Upstream Tech is not a, hashtag AI company. We do use machine learning. One of our products is a hydrology forecast, which is how much water will be in the rivers. And we use some pretty awesome, new techniques that have resulted in the most accurate operational forecast that's out there. So we're sort of in an age of tech bubbles. The last couple of years have been brutal. And I hope that I can provide a perspective that balances out the massive hype surrounding AI. I'm going to talk about the real promise of AI, a promise that I believe has been largely obfuscated by the recent hype. I'm going to caution you as, maybe current or potential consumers of this technology, and outline where it has and may continue to go afoul. And finally, I'm going to talk about AI opportunities that I'm most excited about, and especially in the realm of energy, climate, and water. Okay, promise. AI is not new. It's been around for decades. The field, of course, has advanced massively over the years, but the ambition and vision has largely remained the same. What is transcendent AI? What does AI at the level of a human or beyond look like? And it's not the first time we've been promised an imminent AI revolution. First, a quick term, transformative AI. It refers to an inflection point comparable to the agricultural or industrial revolution, which is like, whoa, hell yeah, right? I mean, probably good for humanity at large. If you take the perspective of as humanity, we endeavor to just increase intelligence, overall intelligence, our overall intellectual capability as a group. But, lots of details around wealth concentration, mitigating existential threats, if you're familiar with the paperclip exercise. But that's beyond the scope of this talk. Maybe I'll do a round two. But the current best guesses seem to be between 2040 and 2050, for transformative AI to emerge based on what I was able to find in conversations. And that's looking at energy consumption, data volume, compute throughput. So is this idea new? Absolutely not. So Simon won the Nobel Prize for economics and the Turing Award for computer science. In 1965, he posited that transformative AI would be available within 20 years. Minsky was the co-founder of MIT's AI laboratory. Within a generation, the problem of creating artificial intelligence will be substantially solved. So what happened? These are not chumps tweeting their AI hot takes on Twitter. These are some of the most brilliant people in the history of AI and computer science. And, 20 years later, bonus round, there was another hype cycle of funding. This one's my favorite little artifact. This Sega's AI computer. It promised natural language processing and artificial intelligence via its Prolog interpreter. Hell yeah. Each of these periods, in the 60s/70s and 80s, these periods of optimism were swiftly followed by what we now call an AI winter, where all of the funding and public interest basically evaporated. And it was due to one thing in both cases, ambitious claims and a failure to produce formidable results. So we need to ask ourselves, is this time different? Are we headed for another AI winter? If you don't think too hard about it, of course, this is different. We have fast computers. We have big data centers. We've got the cloud. Come on. Okay, let's talk about generative AI. I assume that if you're watching this, you've heard of ChatGPT or Gemini, Nay, Bard, or Bing, or one of the Mid-Journey. They're all out there. They're all being slammed in our face. If I opened up the New York Times, there's probably on the above the fold something about one of these things. So many of us have been following this space. Many of us have tried them out. When I polled the audience how many people had tried them, most people. How many people were using them regularly? Not so many people. How many people were using them regularly for work? Just a couple people out of a pretty big audience. So it's an interesting landscape right now. A lot of people have looked at them. A lot of people have tried them. Not a lot of people are using them regularly, and especially not for work. So what are large language models? They're enabled by a scale of computation and training data that was previously not pursued. I think Sam Altman, the CEO of OpenAI, quoted ChatGPT-4's training cost of somewhere around $100 million. And they're super powerful. It's like, a chatbot on steroids, right? It could say some pretty incredible things based on the questions that you pose to it. So powerful, yes. Useful, also yes. But I and many others argue that it's not in the general transformative way that the marketing materials promise. Also, fantastic. XKCD. There are a number of things that large language models are really good at involving text transformation and generation. And I actually love some of the accessibility features made possible by large language models. But shortly around the announcement of ChatGPT, Microsoft published a paper titled Sparks of Artificial General Intelligence. And thinking back to the start of my talk, what are the requirements for intelligence to emerge? I posited a goal in a loop. And so if we ask, what is a large language model's goal? I think when you look at it from that perspective, the goal is to produce plausible output that is ranked highly in terms of its response to the question. A Stanford paper quickly followed Microsoft saying those glimmers and sparks you see are a mirage. And I think that metaphor of a mirage is actually really apt. But let's dive into the fun stuff or the scary stuff, depending on your perspective. There's some really juicy lawsuits going on right now in AI land. One with you know who, and a more important one with the New York Times. In order to apply the power of massive computing and create large language models, you need a massive quantity of data. They consume basically all the content they can, digital libraries, the written internet, video transcripts, etc., and whatever the medium of the generative model. So if it's image generating, it's consuming all the images. A problem arises. Does one get to consent to their data being used as input to these models? What if the resulting LLM produces content that has not glimmers of intelligence, but glimmers of plagiarism? So basically, the New York Times was able to show that they were able to create prompts that cause ChatGPT to produce verbatim responses pulling from their articles. These kinds of models currently prevent plagiarized output using what's called a system prompt, or at least that's my current understanding based on some research. The field moves fast, so maybe this has changed. But the system prompt is literally a prompt provided to the model before you talk to it. It says, pretty please do not show copyright characters, do not be mean, do not do bad things, etc. It's like usually it's gotten large. So DALL-E, which is an image generating model, will not show you SpongeBob, but it will show you animated sponge. Correctness is an important one. We want the answers given by algorithms to be correct. Large language models invent references that don't exist but sound right, facts that aren't real, etc. And that's cutely called hallucination. They could be troublesome, but listen, large language models like killer feature has been touted as like generate code, programmers go fast, vroom vroom. This was a blog I came across that cited the large language model Copilot, which is part of GitHub/Microsoft, introduced a subtle but major bug into their system. So you got to be really careful with this stuff. You can't trust its response. If you're going to use it for coding, you need a very experienced developer at the helm of that shit. I love this one. If you ask ChatGPT to use text characters, or otherwise known as ASCII art, to draw a picture and rate it, it produces hilarious output. This is a running unicorn, 9 out of 10. I agree. Next section, enshittification. This one is scary. We should be worried about this. What happens when generating bullshit costs next to nothing? Content generation is an important facet of capitalism, but it's being flooded, or I don't know, you could argue that one. It's being flooded to an unimagined degree with drivel generated by large language models. When you ask ChatGPT something that the system prompt deems bad, it responds with a predictable slap on the wrist. It goes against OpenAI's content policy. If you search that phrase on Twitter, well, lots of people are running into that. Notice the lovely overlap with crypto. Same on Amazon. Sorry, but I can't generate a response to that request in blue. Pollution for SEO optimization and minor profit. And it's not just replacing humans because, this is better. This technology allows for better naming of tents. It's just cheaper. The cost is, next to nothing. Consider this. Amazon had to cap the number of self-published books an author could submit to 3 per day. It's scary because large language models are going to start training on this wave of new large language model generated bullshit, and it's effectively poisoning the well. It's eating the seed corn, as I've seen it said. It's bad news. But it gets worse. These models have been used to pump out content for young children. As a new father, this scares me. the first time in humanity's history where our children are being exposed to unchecked machine-generated content and really like SEO optimized content. The videos are uncanny. They appear real to a parent, like looking over the shoulder of their child, but they're strange and at times don't make any sense. Really, really nasty stuff. Okay, we're going to put a pin on this because yikes, the last couple of weeks have blown up with all these academic papers. This one is priceless, right? It's peer-reviewed. It's in a journal. Again, there are a couple telltale patterns in large language models. Certainly, here is a possible, brutal. And as of the talk that I gave, it's still accessible. So enshittification is real. And to close out this subsection, this whole enshittification, it really reminds me of Hardin's Tragedy of the Commons, except instead of consuming natural resources, we're poisoning something intangible, something cultural. I mentioned hallucinations. One paper recently showed that hallucinations are inevitable given the structures of the models. So, quote, by employing results from learning theory, we show that large language models cannot learn all of the computable functions and will therefore always hallucinate. And last but not least, you can't rank how these are all terrible things. Large language models are starting to be used as recruitment tools. And early application and research have revealed difficult to inspect and uncover biases, such as preference for male candidates. Right? It ranked more highly baseball over softball as a extracurricular. What's bad is that the architectures employed by LLMs especially are opaque and very difficult to inspect, especially at scale. Right? There are some ways to approach machine learning and AI where there's less of a black box, which I think is an overused kind of takedown of any application of machine learning or AI. But with the scale and complexity of large language models, I think that's especially true. Can I make this play? Oh yeah. Last thing I wanted to show was just a quick video. Sora is the name of OpenAI's new video generation model. It's impressive, totally impressive. I mean, holy crow, look at that. But similar to LLMs, I ask you, what was the goal? And again, I posit that it was to generate plausible videos, generate some plausible content, create videos that pass as authentic, something like that, right? The first thing that people ask was, "Whoa, this is incredible! Is it understanding how the world works? How is there's some sort of physics, so there's the appearance of physics or some understanding of causal relationship." But I don't know, like somewhere around here, the legs do a pretty badass 360. Oh, we'll skip, and then we'll skip again. Oh yeah, they just start like spinning around each other. So cause and effect, physics, not currently strengths of the model. Because that's not part of the goal, right? Its goal is not to understand the universe. So when we look at these architectures, they can't simulate physics. They can only create plausible videos, plausible content. One kind of attempt to give large language models the benefit of our immense and growing doubt. At Upstream Tech, we have what we call hack weeks, where we pause normal non-critical work and pair up in teams to hack on something new. David and Phil, two of HydroForecast's most senior engineers, wanted to see if we could leverage large language models to help us assess if a forecast needed human review. So again, our forecasts from HydroForecast, they are how much water will flow through a river over the next 10 days. So they wanted to see, can a large language model flag one for human review, one where we weren't sure how accurate it was or something. We started by seeing if we could engineer prompts such as simple questions about a forecast. So that did okay, pretty cool. Definitely responded in a way that was plausible for a hydrologist type person. But no matter what we tried, it basically said that every forecast needed to be reviewed. And it pointed out things, but not necessarily things that were relevant to why we would need to review it. In the end, the takeaway was that it would be easier to just build a rule-based system that we had control and insight into, right? Because a large language model, again, not to belabor the point, it wasn't trained with the goal of anomaly detection at its core or with any inputs that were hydrologically relevant. So maybe in the future there will be some more general intelligence, right? Something far beyond the large language models we have today that we can leverage for general kind of tasks like this, but it wasn't the right tool for the job. So takeaway. Powerful demonstrations may be in some cases useful as human in the loop creative tools. Use verbatim output at your own peril. I think there's kind of a pattern that I find revealing. When Microsoft launched the Xbox, they didn't talk about the technical merits of their silicone. The iPhone, right? They talked about listening to music, not the tech that went into the resistive touch screens, right? Or the capacitive touch screens. Blockchain and large language models, they have something in common, right? An obsession with the minor details that users do not care about. You go to OpenAI's website about ChatGPT, and it's not talking about how you're going to use this to do X or like what problems it's going to solve that warrant the investment of money and energy that we are making as a humankind. It's talking about the little tech bits and bobs. So that's an important pattern that has really helped identify bubbles. But what about transformative AI? Kind of back to that, right? Recall that we need computation, power, data. I think that we will have the necessary computation and power. But the biggest question is data, especially with the current trend of enshittification. What scale of quality data will be used beyond the current tech demos? What's being left on the table today? Richard Sutton, who, if you don't know, if that name isn't familiar, is one of the founders of modern computational reinforcement learning, outlines what he calls a bitter lesson. General methods that leverage computation are ultimately the most effective and by a large margin. This really stands out to me as how can we take a lesson from the large language models and scale computation in a way that leads to a better result. He talks a little bit about researchers seeking to leverage their human knowledge in the domain. And I think that's definitely true, right? You can't insert your expertise